Welcome everybody. Today we are going to be doing search and sort methods or whatever functions in C++. I'm also going to use some self-tests to check and make sure everything runs correctly. If you liked the video, please don't forget to like and to subscribe for future content. Alright, let's get started. So first, we're going to have main.cpp. As I said, it's C++. We're also going to need, what do I need? It's search sort.h, I believe. Yeah, search sort.h. Then I'm also going to be using text. Alright, now in text, we're just going to put some random numbers. We're going to use 23, -1, 3, 19, 100, 45, 30, 56, -4, and 20. Alright, 10 numbers. Make sure to save that. We'll just use that for testing purposes, so we don't need that. Now, the main is where we're going to be conducting our tests. So, I guess we'll start on the search and sort methods. So, so we're going to begin with the search and sort method. So first off, we're going to want to do this. Not that. Hashtag if defined. Oh no, right, it's that one. If and div we search underscore sort underscore h, then define. Oops. Okay. And then it'd be copy, Control V. So basically, if not defined, then you define it. Alright. Now, let's see here. We're going to want to include, don't worry about this problem right here. It'll fix itself later. We're going to want to include the string methods, include the IOStream methods, and then we're going to be using name space std. Okay, we're going to be using index underscore t equals int. Basically, on our we'll be using this later in the with some different functions, but for now, just trust me. Basically, we're just saying this index t right here, this variable, is going to be equal to int. So now we're going to be constant array underscore size equals 10. So we're basically making a constant int right here of array size equals 10. No big deal. You should know that. Then we're going to start the class search sort going to be public colon we're going to do this. Okay, so we got our pub. Now we're going to do the standard integer. All the variables. No. Okay, oops, not that. That. And we're going to be using this a lot, so you might as well just copy and paste it in here. Enter int. And then the clone. Close it. Int swap count equals 0. Int slide count equals 0. Let's see here. And then int recursive call count equals 0. Okay, now that is done there. So then we're going to start with the first small method. It's just cloning the original array. Clone original. Okay, so now in order to do this, we're just going to use a for loop. For int I equals 0. I is less than or equal to array size. And we'll make sure that's -1, so it doesn't, because you know how arrays don't have a 10. Because this is 10, it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no 10, so that's why you're doing -1 here if you don't know, but you should already know how to do that. Next, we're going to do, and then I++ here, and opening that. Now, and then we're just going to go clone of I equals original of I. And that should be good. Is that right? Yep. Okay, so next we are doing this search sort. Oops. Search sort const int original Okay, and then doing that, put the brackets there. Then we're doing another for loop, which I'll just copy this from here, Control C, Control V, and then let's see what we need to change. So it'd be this with a pointer equals original of I. Okay. Next. Oh wait, that's it. Okay, so that's it for our constructors. Now, what else do we need? We're going to do void selection sort right here. Oops. And what's going to be the? There's not going to be any. There's not going to be any parameters in that, so we're not going to do that right now. But this one, index underscore t, index of smallest element, then int start at, and then basically, as we said earlier, this int t is just another way to say integer right there. Index t is just another way to say int. That's just the return type. So we're just returning an integer here. No big deal. Okay, then we're going to do void swap int index 1, comma, int index 2, close. Basically, we're just swapping these two in the clones. So that's easy. That's easily done. Let's see, what else do we need? We're also gonna do an insertion sort. So void insertion sort. No parameters there. Okay, now what else are we gonna do? We're gonna do a binary, recursive binary, that is. Recursive binary search. Okay, this one is going to have an int middle, int haystack, int from, int to. Okay, that's going to be a bit complex if you don't know what you're doing, but since we can use recursion, it's going to make this a lot simpler. And as always, we're just returning an int. Okay, now we are going to start with, I guess we'll just start at the beginning, selection sort. Okay, we're going to make sure our, so as I said, we're going to start with selection. We're going to make sure our swap count is at 0 first thing, because it's just easier that way. Tab that over. Now, our swap count has to be 0. Index underscore t equals, index 1, close. Now, we are going to clone the original first thing. So we're going to clone the original array in order to make sure so we're going to clone the original array first, and then, sorry about that, then we're going to go for a for loop. So for loop, and then we're going to go int I equals 0, close. I is less than array underscore size. It's -1, I believe. Yes, it is. And then it's I plus plus. Now, next thing we do is going to be index 1 equals index of smallest element. Then this will be I. Yeah, okay. So yeah, we find if that is the smallest element in the array, and then do that, because it starts at I, because the ones that are before I have already been sorted. Yes, okay. Next thing, we do a swap, swap of I and index 1. Okay, I believe that is already done. What's all these? Expected that, yada yada yada. Why would that need that? Oh, okay. So I forgot to do this. At the end of that, that needs that. Because then we'd have to close that. Right? And then we need the hashtag and diff. Right? Is that right? Let's see here. Oh well, we'll just go through this and then work on that problem later. Now, index of the smallest array. This is a bit tricky. So I'm going to do index underscore t equals index close. Oops. I screwed that up. Index equals start at. Okay. Now, we're going to do another for loop. And then it's going to be int j equals start at j. Oh no, it's not start at, it's start at plus 1, j less than array size. Array underscore size j plus plus. Okay, that's done. So now if clone of j is less than equal to clone of index, then you want to index equals j close return index close. Okay. Identifier clone. Okay, yeah, most of these should go back once everything has been dealt with. Is that it? Okay, I just had that misplaced then. Alright. Okay, so now that's done. Index of the smallest array. So, yep, okay. Now we're going to do the swap to easy. We're going to do int a equals clone of index 1 close index 1 oops clone index 1 equals clone index 2 clone of index 2 equals a close. So there we go. Oops. Let's see here. Tab that over, tab that over, tab that over. Okay. Now, insertion sort. So now this is going to be easy. We're just going to clone the original. Then we have to do slide count equals 0, close, enter. Int j 4, int I equals 1, close, I less than array size, oops, close, I plus plus. Now, okay, so j equals I, close that, while j is greater than 0, and clone of j is less than clone of j minus 1. Okay, now we're gonna so basically they're saying if j is greater than 0, and okay, so this has to be greater than 0, that's why it's starting at 1, and clone j has to be greater than the 1, has to be less than the one before it. We then swap j with j minus 1. Then we want to do this. We're going to do slide count plus plus, close, minus minus j, close. Okay, yep, that's it. Now, we're going to do this one. Okay, this one's going to take a good chunk, so just follow along as best you can. Pause this video if you need it. So, if open 2 is greater than or equal to from, no, not that, equals 0. Yep, that's it. If 2 is greater than or equal to 0. So that's just basically base case. That's basically the base case right there. So we're going to do the mid. Int mid equals open. Oops, not even that. From plus 2 divided by 2. Close, enter. If a stack of mid equals needle, return mid, that is else, oops, else if Control C, copy that because we're going to do this, and then if haystack mid is greater than or equal to the needle, then we do this. We're just going to be cursive call count plus plus, and then we're going to call this again. recursive binary search with needle, comma, haystack, comma, and then it'd be from, comma, and it'd be mid minus 1. So basically, we got a haystack, an array, and if the mid of that array we're given is greater than or equal to the needle, then we do this. But it won't be equal to because we already have the equals right there. So we can probably forget that. But we're just going to do this anyways. So that means is greater than. So the 2, that means the needle has to be less than the haystack. So that's why we put the 2 as mid minus 1 because we already checked mid. Okay. So that's done. Now we do else, and then basically we can copy this and then switch this around. This would be mid plus 1, and this would be 2. Control save. Alright, and then let's see here. That goes there. That goes there. Then and just in case 2 is not greater than or equal to 0, we have to make sure we return -1. That's just saying we didn't find it. Alright. So we already coded everything in the search and sort. We are going to start coding the main method next. But this is where I'm going to stop for part 1. Like, comment, subscribe. Thanks.